Okay, so this is going to be about formal charges and how to find formal charges and why we would use formal charges. Okay, so I'm going to look at this first one. I know the diagram is small, so I'm going to try to draw it bigger here and explain what's going on. So we've got silicon dioxide here, but when we draw the Lewis dot structure, there's two ways to draw the Lewis structure. Both are viable, but how do we know which one will be right? And when both, oh, I totally drew that wrong. Excuse me. Let's see, boom, 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 boom. Si triple bond O to a lone pair. Okay, so if we look at both of these, they have 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16 electrons. And this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 electrons. We have 2 oxygens, so that's 12 electrons plus silicon. Which if we look at our periodic table, silicon is right here. And so that's going to be bringing 4 electrons added together, that's 16 electrons. So both of these have 16 electrons, so both are viable. So what we have to do is find the formal charge to figure out which will be the correct one. So here's a big diagram, but I'm going to try to sum it up without the questions in this one. So SiO triple bond O. And so basically finding formal charge is, I will write the formula. Formal charge equals the number of valence electrons, VE for valence electrons, minus number of formal electrons. So valence is the one that I think of. This is what I think of as brought. And this is how many it has. Okay, so oxygens bring 6 based on their position in the periodic table. So since it's in 16, don't look at the 1, 6, and so it's 6. So across the top, 1, 2, 3, 4, 5, 6, 7, 8. And that's how you're going to figure out how many valence electrons that particular molecule is based on the group. Okay, and so silicone, same thing. Right here, so there's silicone, and so it's in the 14th, so 4. Just looking at that ones place digit, so this brings 4. So the way I think about this is I draw a line down the bonds, because in the bond, one will go to this atom and the other will go to this atom because the line represents 2 electrons. Okay, so silicone has 1, 2, 3, 4. Okay, so 4 equals 4, so the formal charge of silicone is 0. Not really sure how you write it, just kind of going to denote it right down there. So this oxygen has 1, 2, 3, 4, 5. So it has 5 electrons minus the 6 electrons it should have brought. I'll call this O1. The formal charge equals 1. But we look at this oxygen here, 1, 2, 3, 4, 5, 6, 7. So it would be 7 minus 6 equals negative 1. Okay, and so if we add all those together, the charge, if we add 1 plus negative 1, it equals 0. So the sum of the formal charges equals the charge on the particle, which is why this one's 0. But as we can see, this one has a negative 1 formal charge. This one has a 1 formal charge. Basically what formal charge is used for is to find out what structure would be best. So to do that, we're going to look at this structure. Right here's formal charge, and I'm just going to draw it right down here. So we have an O, double bond Si, double bond O, 1, 2, 1, 2. Okay, so we're going to look at the formal charge. So this has 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, and then this one 1, 2, 3, 4, 5, 6. 6 minus 6 is 0, so the formal charge would be 0. Formal charge would be 0, 0, and then a 0 equals 0. So because none of these are off of the formal charge, this would be the best, or most likely, form of it. Now you can do this for bigger structures as well. So when I broke this problem down right here, between structure A and structure B, see, this structure B is going to be better because if we look at, I generally look at the bigger ones first. That's what I did. So looking at the oxygen, 1, 2, 3, 4, 5, 6. Once again, just envision a line about right there. Just dividing the bond in half, one for each. So 1, 2, 3, 4, 5, 6. That's how many it's supposed to have. Nitrogen in is right here, so in 15, so it's supposed to have 5 valence. 1, 2, 3, 4, 5. Where in this one it has 1, 2, 3, 4. So that's going to be 1 off. So this one, and then hydrogen 1, 1, 1, carbon 1, 2, 3, 4. So this one is good, and that would be the one which is better for it. Hope that was helpful.